All right. I'm going to say good morning, everyone, because I'm out on West Coast time. As you might imagine, if we're doing artificial intelligence, we have to come out of the Silicon Valley. I'll try and keep my references to the show, the Silicon Valley, at a minimum. But there is one that I just can't resist that has to do with artificial intelligence. So let me jump into. Let me tell you real quick about myself. So I work currently with Everest Labs. Everest Labs is involved in artificial intelligence and automation of MRF tools, specifically robotic arms. We're going to focus not on the robotic arms and the automation today, but on the data that AI can provide and deliver, and how that really fits into this better recycling movement. What I hope, let me make sure I can, okay. What I hope to accomplish today, and I think we can open it up for Q&A or other comments afterwards, is just really an appreciation of the momentum behind this better recycling movement, understanding of the quality of data that really is available with AI technology now, and specifically computer vision and AI. I've come to believe, right, and I've been working in the solid waste industry for about 30 years or more, that the MRF really is an excellent source of information and really a proxy for the health of our recycling systems. And I'll give you my insight on that here in just a few minutes. And then I want to talk about, just easy steps really to take now, this idea of the use of AI to really gather data and then start to make decisions based on that data. Nothing to sort of be fearful of, right? You don't have to be an early adopter of technology or anything to that extent. I want to thank Rob Watson and Sweep. I've been participating with Sweep for about 2 or 3 years now, and just the development over time of that performance protocol is fantastic. And certainly I know Rob is a big proponent, big believer in use of data for making decisions. And frankly, it's where my title comes from, just the data driven to better recycling. So let me switch over real quick. I want to talk about better recycling and my concept of why is there so much momentum behind this. I don't think it should be any surprise. I was searching on the internet yesterday, looking for articles about investment in recycling, focus on recycling, public education programs. Everybody who's online can do the same. And my guess is you're going to find hundreds of articles every day that talk about it. You yourself being here, listening to Sweep and this idea of data driven for better recycling, you're testament to it, right? There's just a ton of momentum that's really self-evident every day with, corporate commitments to ESG, manufacturing responsibilities, technology innovation, public education. Think about everything that goes into that on a daily basis that you can see. And I guess I challenge anybody to sit back and say that, oh, we're good with where we're at. We really don't need to worry about, better recycling. I would be at a loss why anybody could take that position because of this investment, all this time that's devoted to it. And so again, that's kind of my premise of we're always striving to do something better and different. And again, this is the idea behind how you can now make use of computer vision and artificial intelligence. I don't think we're moving away from data anytime soon in the solid waste sector. In fact, again, referring back to sort of my searching around or poking around on the internet yesterday, I found everything is really based on data driven, right? Investment criteria, performance criteria, numbers. Why is that, right? We've been using it for years in this space, in this recycling space, in this solid waste space, because it justifies investment and spending. We use it to optimize operational systems. We want to get peak performance out of those operational systems. They're expensive, and so we obviously want to use them as to the best of that capability. It's a credible tool for evaluating, total cost of services, right? This data, what does it mean to us? Are we getting a return on our dollar, for example? And more so, it's becoming necessary for reporting on ESG objectives and compliance regulations. And I have a sense, everyone, that it's going to be a big driver of extended producer responsibility, as that seems to be gaining more momentum as well. Long and the short of it, the data is absolutely critical for better recycling. There's no way, there is no way around that. It's also something that I want to say is, in my experience, it's expensive, right? It's cumbersome, it's time consuming. It's sort of a real kind of pain to get to this data that is so elemental to us and so valuable to the industry. We dig through and characterize loads of material coming off of trucks. We sample what's at transfer stations and MRFs. You can see them, right? You can picture them in your mind. You see crews of 10, 15 people going through, loads or sample loads of material, sorting them into buckets, weighing them, on and on and on, right? These are activities that'll, $50, $100, $200, $300,000 endeavors. Great information that comes out of it. Everybody loves it, right? And it sort of forms the basis for kind of the next move, either with a program or with an investment or just an operation, how to sort of optimize it. But there's probably not enough of it. And it's not on an ongoing basis because, again, it is cumbersome and expensive to do it in that manner. This is where technology really can come into play. And it is computer vision. On my screen, you'll see a simple computer vision camera sitting over a conveyor line in a MRF. The cord coming out of it, right? It's umbilical cords connected to the brains of that computer vision. So AI, and thanks, Jill, for taking that poll. So AI and this computer vision, what is it, right? It's a video camera is what it is. It's a very specialized video camera, but it's a video camera, and then it's taking that video feed and pushing it through what we call GPU, right? It's a GPU processor running artificial intelligence software. And that artificial intelligence software is looking for patterns, for data points that it recognizes, so it can tell you, do you have a PET bottle on the line? Do you have an aluminum can? Do you have a piece of paper? How big is it? Is there a brand of it we can recognize with it? It's really sort of set up, on one hand, it was kind of developed to say, hey, we can power robotic arms with it, but where it's now really headed toward, it's not headed away from robotics, but it's where it's really headed toward now with as far as value is it really shows and demonstrates and sort of visualizes patterns. So you can kind of tease out some pretty critical trends in what you're seeing in those patterns. You can give valuable feedback to programs and investments. Just a quick side, I have a user of Everest Labs vision technology right now. They did a $3 or $4 million equipment upgrade out of MRF, and they wanted to know, are we getting the bang for our buck with that equipment, as well as what else do we need to do now? What else is that equipment still missing that we can see? And now, because we have data every day, we know it's either consistent or inconsistent, but we can justify some additional expense. And that's what this idea of this counting is all about. Let me jump down to the next slide. So I think probably most people have seen this concept of computer vision, right? Where it's literally a video camera, but it's taking the AI is actually taking and putting these, what we call these bounding boxes around these objects. And when the AI or the data can see what it is, it's going to label it, right? So it's going to label it as HDPE color or aluminum can or PET water bottle or film plastic. And what's really, exciting is previously you had to, run belts at fairly slower speeds to be able to recognize this stuff. But now with the type of cameras and the processing speed that's available with our systems or with other computer vision systems, is you can get speeds up to 500 feet a minute. We're even trying to take stuff up to 1,000 feet per minute. Why is that interesting in the recycling business? Now you can put these cameras on the front end of optical sorters, for example, and get information about what's being fed into that optical sorter. So again, all data that's readily and affordably available. Our engineer, which I don't think there's a more difficult engineering AI application than in the waste business. Because if you think about how many different form factors of a PET water bottle are there out there, thousands, tens of thousands, I don't know, but you have to set up your AI so that it can recognize each and every one. And we have somebody on our staff, for example, that came out of the self-driving car industry, and he goes, at least in the self-driving car industry, we've got a little bit of time to make a decision on this thing within a MRF environment where we're trying to count these objects and recognize them in real time. You have a millisecond or less sometimes, but that's the power of the computing capacity that's available now to put on site in plants. One of the things that I think is important that you also want to keep in mind is, processing power, bringing it on site. Don't put it in the cloud, right? In the cloud, there's a lag, there's a delay, and there's also issues of data protection. With that cloud environment, as secure as you want it to be, it's always nice to have it not real-time networked, frankly, but running that power on site. And then I oftentimes get asked as well, how do you know that the vision system is seeing what it sees? How do you know that it's reporting correctly? And I would say that one other necessity when you're using computer vision and AI is to make sure that that provider has an audit process or an audit program. I'll give you an example. Our audit program at Everest Labs is, at the end of the day, a backup and a sampling of information or of classifications that come out of our systems every day. There's a set of human eyes that gets put on that, okay? Because we haven't found any AI that's better at recognition than human eyes, but because we're processing, millions of objects a day, you're going to take that sampling, and that's your credibility. And that is key, because AI, right, it can go awry sometimes, and so you do want that audit process to it. I'm going to sort of move into this realm now of why do I think recycling facilities provide such value. So I have a few slides on that. Listen, they're the epicenter of our recycling system. More on that to come, but they also provide such a centralized location where you can collect all of this data affordably. And let me dive into a couple quick examples, right? I would just say that my screen right now has some shots from a platform that we run with computer vision feeding into it. And you can see, right, we're trying to develop, are there patterns? Are there hiccups in a system? What do the loads of material look like? This gives you insight into what's the consumption patterns any given week or month or season of the year. We often can tell a MRF operator when their equipment needs maintenance. Think about paper screens or disc screens. When they start to wear down, there's a difference in the material that they generate, and we can oftentimes help that operator see that in advance, because we'll see these pattern shifts in materials, too many aluminum cans coming through now, or too much paper sort of working its way through the system. Again, just some intelligence and insight into this. We can break down, we do ourselves, 21 classes of materials that you can isolate and segregate and count objects. And we're adding more all the time. We're looking to add in batteries now by type. Batteries are an issue in MRFs, not necessarily from a recovery standpoint, although important, but a safety issue, right? Fires. So those are now being added into our classification system. This is all based on counting each and every object. And one thing I want to note is, I over the course of my years in the industry, I had great opportunity to work with equipping MRF environments and either spot equipment or wholesale changing them out. And a lot of people focus on tons. How many tons of throughput can you get through the system? 35 tons an hour, 30 tons an hour. I really believe since I started working with computer vision and AI, that it is all about the object count. To me, tonnage takes on less and less importance, because I still need to, if you think about it, a MRF still needs to grab or take hold or isolate or segregate each and every object. And a tonnage count really doesn't do it justice about how much work is going on with that MRF or with robots or with optical sorters or with humans pulling this material. And so that's why the computer vision, it can't use weights because it's not programmed to do that, but the object count is where the real value, I think, comes into play. These systems really, I showed you that picture of one of our systems, for example. You can put them on any line you want to. We tend to focus on kind of the big three types of data points that are really important to MRFs. You know, what's the composition of the waste? What can we sort of understand and see as far as what's coming in and what's leaving the MRF? What's the leakage of material? You know, is there a lot of good quality or valuable recyclable materials or objects that the equipment and or the hand sorters are missing? Where is it ending up in a MRF? Is it on a residual line? Is it somewhere coming out of a container line? Is it on a paper line? Because that information is going to give you an indication of where in my plant is something leaking, right? Where is the equipment not performing, or where is the equipment overloaded because we're putting too much material across the line? A lot of different conclusions can be drawn by that. And then we also look at revenue opportunity. What's the capability of this MRF, again, depending on where you're measuring, to actually recover additional material that might be leaking? You know, is there a way to charge differently for this? Every MRF operator charges a processing fee. Am I charging the right amount based on the content or the composition of the material coming through the plant, the recovery of the material? And you can see that, again, all of this automated data collection, we can correlate that with value. We know the value of containers on a per container count. We know the value of paper. Oftentimes we do some estimates on the size because we can tell the size of the paper. You know, anyway, so this is the type of information that really can go on one line, can go on many lines within a MRF. I'm gonna do something that should never be done on a slide, right, and put a ton of words on it and totally overwhelm everybody with words. But I wanted to really put this on one slide so I could talk through it real quick. Again, my premise is the MRF really provides a temperature gauge or assessment of the recycling system health overall. And I believe that for these reasons, right? Let's look at sustainability. If I'm seeing leakage of good, valuable material in a plant, I can, you know, a healthy system, to me, a healthy recycling system is one that's going to focus on high greenhouse gas emission savings, carbon offsets. I pulled a graph from one of our platforms that gives you an assessment of what's been captured, what's available to capture. This is coming off of data or calculations that's available with the EPA, the WARM model that everybody's probably familiar with. If I think about baler-bound material, and I'm talking about material not necessarily on the baler in-feed line, but material that's been recovered, that it's sort of last chance, it's going to be headed toward a bin or a hopper where it's going to be stored prior to baling. But what's the quality of that material? Because that quality of material is the stuff that's getting put back into the closed loop system. And it's also an indicator of what revenue did the plant operator, what were they able to glean from that inbound stream? Again, given all of their limitations, given the equipment that the MRF has, given the way that they can staff it, given the quality of the equipment, given the quality of the waste composition. Really important considerations for, is my recycling system healthy or not? Equipment output, again, same idea, really depends or can depend on waste composition. What packaging is ending up in the right place? Remember, I say packaging because we don't handle anything in a MRF that's not packaging. It truly is all packaging. Is it ending up in the right place for recovery or not? Are containers ending up on the paper line or vice versa? This can be an indication of again, health of a system. Manufacturers, right? This is where I think EPR and some other concepts around EPR can come into play. Manufacturing packaging, depending on how that packaging is constructed, is it ending up in the right place on a MRF to make it easier to recover? Again, to me, high leftover packaging, for example, unhealthy system, not a healthy system. Lost revenue, we already sort of covered that leakage issue. And then consumption behavior. really what is that composition of material, not that's being purchased in stores and whatever, but actually is ending up in the recycling can. Can we see that there's a good ratio of recyclable material versus material that's not recoverable that's ending up in the can? Again, gauge of the health of a recycling system. All of this, right, is available. Everybody loves this kind of information. I just suggest that let's focus on what's available from the MRF or from the recycling plant. Because we can gather so much data automatically, we don't need to go out to the truck. We don't need to go out to the curbside necessarily. We can do it all in one kind of centralized location with computer vision now. A couple last comments. Really, I said it was sort of easy to get going with this and this type of information, kind of this one step at a time sort of approach. I would say if you have a recycling plant partner or you're a MRF operator or whatever, you can install one vision system in a key location where you want to say, I really wish I knew more about that location in our MRF. You don't have to, think about, wow, this is so overwhelming that it's difficult to start. You can start in one spot. I guarantee you the data and the insights will pay off almost immediately for you. I think it gives you the opportunity to sort of step away from, really expensive, cumbersome, and frankly, variable waste characterization studies and assessments and periodic sampling. I think, again, this concept now that you can automate this data acquisition to drive you toward better recycling in so many aspects of your recycling system is really available nowadays. And then again, I'm a proponent of let's convert to thinking about object counts. Really, weights aren't that meaningful to better recycling. Just think about light weighting of packaging, right? How many water bottles do I need to now recover to make a ton of PET versus how many I used to have to, capture 5 years ago? What's the biggest impact on my recycling system? The biggest impact is I now have to recover a lot more objects than I used to. And that takes personnel, or that takes equipment, or that takes investment. And it's very different than it was 5 years ago. That's just one example. So again, keep calm and always recycle. I want to turn it back over to, I think, Rob now or Jill, but I'm going to stop sharing my screen. If you need to get a hold of me, have other questions, I'd love to follow up with you. I can talk about this, for hours. But please do reach out, Don at everestlabs.ai. Would love to chat with you further. And again, I'll stop my share now and flip it back over to folks.
Great, thank you, Don. We do have one question while Rob gets set up here for you. And that is, can you talk a little bit more about how AI can help reduce contamination levels?
So I think AI, so there's a couple applications of it, right? If I look at composition of material coming into a MRF or through a MRF, I think it gives me data and information to now go back to the generator of the material and talk about what's going on with your programs where we're getting either an increase in contamination or a reduction in contamination, either way, right? It can go either way, but it gives me that real-time information to go back to that producer of that material and understand what's going on. I think one of the kind of cool aspects of being able to read this on an ongoing basis is if somebody's invested in an education program to try and drive down contamination or to drive up the quality of recyclable material, what has that netted? What's the net gain? Because at the end of the day, that material is still coming into the MRF. And are we better off or worse off with that investment in that education program? Now we can see it when we monitor this stuff in a MRF. The other aspect of AI, if you think about contamination, is if you are going to, on the back end of AI, equip robotic arms or other recovery equipment, you can now address that contamination in a much more precise manner because you can direct your automated equipment to specifically target those types of contamination and hopefully clean up your stream to some extent as well.
Great, excellent. Well, keep your questions coming. Be sure to post those in the Q&A. We'll bring Don back after we hear from Rob and how all of this connects to what's going on in the sweep world.
Thanks so much, Jill. Don, great presentation. It's been a real pleasure working with you on developing the sweep standard. Look forward to you keeping us at the forefront of progress in data and measurement and characterization. So, we've done a lot over the last few years in developing SWEEP as a suite of triple bottom line sustainable materials management standards. Our key constituencies are local governments and the material management industry that provides waste management services to those. And our goal is to try and integrate policy and practice to create a sustainable materials management system. SWEEP, not unlike the LEAD system, which I started back in 1993, is designed to identify and reward leaders in sustainable materials management. And it provides third-party recognition for the performance of both companies and local governments. And the value of third-party recognition is very significant because when I call myself an environmentalist, maybe my mother might believe me. If my mother calls me an environmentalist, maybe my immediate family might believe me. But if somebody I've never known on the street, just says, "Hey, that guy's an environmentalist," then a lot more people will pay attention, regardless of how much I do, right? So having that independent arm's length evaluation of your performance gives much more credibility to your claims of achievement than any self-promotion might. And as Don indicated, we really need to move toward a new standardized basis for characterizing materials, for classifying them, for establishing their value, their volume. And we have economic value, we have environmental value, which are not always in sync. And so the ability to parse and tease apart these different values and assign these values with a little bit more precision is going to be a very important contribution, I believe, of artificial intelligence, as well as automated systems such as the robotic arms of Everest Labs. SWEEP is a point-based system, again, stealing shamelessly from LEAD, although the SWEEP 0 system, which I'll talk about in a second, will be a pass-fail. But at the end of the game, at the end of the day, the goal of this system is to transform the market. So, that market, if sort of looks like this. If you take the bell curve where you've got your innovators and your early adopters, your early and late majorities, and then your laggards who will probably never do anything. The SWEEP Plus standards, which we've launched and are in pilot right now, is focusing on some of the innovators, all of the early adopters, and some of the early majority. And then SWEEP 0, which is probably the next standard that's going to be out of the chute, will come and focus on the very top innovative category of people in the waste management system. And then we're going to have a mid-market standard called SWEEP, which will focus on not only sort of the absolute achievement, which is the focus of SWEEP Plus, but also relative improvement. And so stay tuned for processes that will begin developing these standards. They will have very similar structure to SWEEP, although the performance criteria and some of the credits will look different. We are always looking for volunteers. If you are interested in volunteering on a SWEEP committee, becoming a member of SWEEP, please write us at info@sweepstandard.org. And I think Sam and Will post other ways of contacting us in the chat. So we are all familiar with Peter Drucker's famous statement that you can't manage what you don't measure. And our corollary at SWEEP is that you can't measure what you haven't defined. And so that's one of the key aspects of developing a standard, is having a consistent and common definition of key elements in the waste management system. And no category in waste management is more in need of this than waste characterization. And even the assessment of the problem, right? EPA says that 260 to 270 million tons are disposed of each year, but the people who are actually out in the field counting, Waste Business Journal, Biocycle, EREF, Yale, have all done field sampling methodologies as opposed to a simulation model that was built back in the 70s. And they're all saying that, in fact, the problem is in the 430 to 460 million tons. And I don't know where you're from, but where I come from, you can't solve a 460 million ton problem with 260 million ton solutions. In the waste field, and as we move towards sustainable materials management, one of the biggest problems is inconsistent waste characterizations. As we've heard from Don, and hopefully, AI and some of these separation technologies will make this a significantly more efficient and effective process. But right now, waste characterization studies are expensive. They're difficult. Most are several years old, in some cases approaching almost 2 decades. And it's almost impossible to find 2 surveys that are identical. Here is a case in point. I looked at 4 different waste characterization studies, and not only were the top level categories different for not only the way the material was characterized, but the order in which it was characterized and reported. But then we go under the hood and we look at how plastics themselves are characterized. And you have as many different groupings of plastic categories as you have different types of plastic. So it's the joke that, you look at 10 waste characterization studies and you come up with 11 characterizations. So what we hope to do with SWEEP is to regularize this process, have a general and consistent reporting at the top level, as well as consistent lower level categories. We're looking for people who are expert in this area to help us. So please drop us a note. And then, the even basic definitions of what diversion means, right? HDR did a study, benchmarking study for Montgomery County, and it looked at several counties, including Montgomery, and they used a consistent set of diversion calculations. And for example, in Seattle, they found that, the Seattle folks pretty much were right on. What they reported was what, would be calculated using a consistent benchmarking for diversion. Minneapolis was actually underreporting based on the HDR set of characterizations. San Francisco, on the other hand, their vaunted 80%, which is probably one of the best examples of waste data being garbage, is actually in the upper 40s, perhaps low 50s, if we squint. But, you can't just put dirt in the equation and expect that to actually be considered recycling, which is what San Francisco does. So please do yourselves a favor, stop repeating San Francisco's 80% number. It's nowhere near that. And then Toronto, again, is kind of in between. They reported slightly higher diversion than what would be calculated under the HDR methodology. So, the SWEEP is going to try and have a consistent methodology. And so that when you look at 2 SWEEP certified programs, you will find that the characterization of generation, of diversion, all these key topics are normalized. And even inside waste characterization studies, you've got significant problems. So if you look at a zero waste report from a city that will remain unnamed, metal is characterized at about 3%. So in that waste shed, about 2.2 million tons were generated. So simple math indicates that about 66,000 tons of metal would be recovered. But then you go to the detailed breakout, and you find that white goods, and you've got aluminum scrap and cans, and ferrous metals, mixed metals, non-ferrous metals, steel and bimetal tin cups. You add all that up, and it's almost 600,000 tons, or 27% of the total waste stream. So obviously, there's, even within the same waste characterization study and plan, there's a gigantic difference in the way things are reported, and not only is the inconsistency internal, but it's also significantly inconsistent compared to what the share of metal is in the U.S. average. So, one must ask what is going on. Personally, I think that for some reason within this zero waste plan, at least at the detailed level, they're including car scrap. That's the only thing I could think of that might generate those kinds of numbers. And as far as I know, those are not typically counted in the EPA averages, because basically, the auto scrap is basically a different supply chain and has a different set of it has its own internally consistent infrastructure. That's anyway. I'd love to hear what other people think might be going on within that same zero waste report. So obviously, to fix the problem, we need to develop a uniform system of material classification. And look, if we get to 80% consistency, that's good for the first start. And to do that, we need to develop a methodology for assessing diversion and disposal. And that's what we have a couple of ad hoc committees under development. And please join if you have an interest in fixing this problem. So we're trying to establish common definitions and measurement. We believe that data transparency will lead to better decisions and more effective and efficient operations. As Don pointed out, when you find problems in your system, you can plug those leaks, right? That's almost the first job of small is beautiful. Local self-reliance is ensuring that all the leaks in the economy are blocked. And so AI combined with blockchain and the potential to go to real-time supply chain data analysis, there's a huge, I think, potential economy there. You take things like Holy Grail, which might be able to contain full or partial life cycle assessment of that bottle from where it came from. You might even ultimately, if we start going to highly centralized mixed waste separation systems, where rather than only being exposed to the material that consumers choose rightly or wrongly to separate, that everything in the waste stream starts going through these centralized facilities, and basically, taking the principles that, quote, normal MRFs operate on, but, facilities that are actually designed to separate the entire waste stream, because, everything in the waste stream has density, dimension, and optical properties. The machines that separate on these physical bases are well established, and it's actually, there are a couple of facilities in Europe that are already separating mixed waste streams into 40 or 50 clean and consistent material streams. And once garbage mixed materials are separated, they stop becoming garbage and they start becoming feedstock. So hopefully, between better sorting capacity, AI, and life cycle field tracking, we'll really be able to manufacture the infrastructure for a circular economy. So clearly, data and measurement are important in SWEEP. In fact, 2 of our 3 prerequisites have measurement and data at their core. At least 5 credits require significant data measurement, waste characterization, et cetera, which total at least 30 points in the system. So, if you do a good job on your data and your waste characterization, you're more than halfway to SWEEP certification. And, over time, we'll be more and more interested in the actual recovery and actual post, processing performance. right now, first standard coming out of the box, we're going to be focusing on establishing the platform and the foundation for measurement and evaluation and assessment. So then we can build on the post collection reporting after that. So our first prerequisite is, comprehensive sustainable materials management policy and programs. We've all seen this sort of SMM, sustainable materials management loop. SWEEP sort of focuses on the left half of that, more or less, everything from recovering to sourcing. But the dark side of the moon ends up, being sort of the manufacture, distribution, and use piece. But with things like Holy Grail and AI and the ability to put digital watermarks and things and track it, either coming into the factory, coming out into the waste collection management system, we now have the ability to get a sense of what's going on that dark side of the moon. And consumers, when they're in the grocery stores, that maybe take a QR picture of it, say, oh, this has got a great life cycle profile, I want it, this one doesn't, I'm not going to buy it. So I do think we're going to really see some very, very interesting data and technology advances in the near future. And then, consistent with this prerequisite, our largest credit in the standard, the Comprehensive Sustainable Materials Management Lifecycle Analysis and Policy Program. Again, that's either that's an integrated performance-based system. So waste characterization and data measurement are very important. The goal of this is to try and minimize the disposal per person, but also understanding what the recovery is and understanding what the 10 most environmentally damaging materials are, and emphasizing programs that recover that. So we ask that you either do a warm analysis and look at a single metric, which is carbon, the total embodied carbon in a particular type of material, and then what are you going to do to recover that material and reduce that footprint, or a more comprehensive life cycle analysis, again with the same goal. Pick your top 10 materials and design programs to enhance the capture of those programs. And then later on, we also have a similar credit more on a prescriptive basis that focuses on the data and assessment part of that life cycle, but not necessarily one where you've done the comprehensive policy. And regular waste characterization and generation studies are credited. We want people to have the most up-to-date data and understand how materials flow through their town, how much is coming from visitors, whether they're commuters, whether they're tourists, and then how much are coming from residents. And then that way you can design your programs to more effectively capture and maximize the economic and environmental value of your program. Similarly, our prerequisite requires that you measure and calculate waste generation, recovery, and disposal. And this is at a more basic level, but just making sure that it's sort of like defining a problem and then measuring it so you can manage it. Going upstream, again, I've talked about the dark side of the moon and, how do we actually impact and build markets for these recovered materials? And, one, weak link, but it's one that is available to us, is to use the environmentally preferable product procurement for non-capital items, office paper, that sort of thing, and the ability to track EPP through AI, through these digital watermarks, both when you're procuring them and then when you're sending them through your system. Hopefully we'll be able to create, this full circular supply chain. And then in our post-collection recovery category, PCR, we give credit for minimizing contamination. And again, the materials and tools that Don, the processes and tools that Don described would be very helpful in achieving this credit. And then, trying to build a more compact supply chain. So if you're tracking materials through your facility, you ought to be able to track them to where they're ultimately disposed of, whether they're going to a local distributor who then sends them somewhere else, or whether they're going straight to a local recovery and processing facility. And then that's how, AI at different points of the supply chain can help us keep track of this, and blockchain can ensure the integrity of those counts. So that's data in Sweep in a nutshell. If you want to get involved with Sweep, and we hope you do, you can visit us at sweepstandard.org. You can download the standard. We've got descriptions of all the committees and all the opportunities to participate with us. Become a member of Sweep. We have probably about 4 dozen members now, local governments, private companies that are all seeking to build the growth of sustainable materials management and the Sweep system. Membership gives you a role on committees, and it also gives you discounts for Sweep certification and other products and services that Sweep provides. We are in the process of greatly expanding our professional committees. This is where the rubber meets the road, and this is your opportunity to build a legacy in your field. So you can tell your kids and your grandkids that you helped change the materials management industry. If your company or your city is interested in being a pilot participant, we have some openings for pilot participants to join the program and help us improve the system. And you can be the first kid on your block to be Sweep certified. And if you want to connect with us, we're on social media, and you can also contact us by sending an email to info@sweepstandard.org, or if Sam and Will have shared their emails in the chat, then you can reach out to them that way as well. So thanks so much for participating. I think we had a couple of other poll questions.
Yeah, I have some questions lined up for both you
perfect, Sam.
and Don.
Yeah, looking forward to some Q&A.
Yeah, great presentation, super interesting. 2 questions for Don. I think, Don, you might have answered this just to the panel in the chat, but if you could just answer it for the benefit of everyone. This is from Daniel Hartzig. He says, I can see the benefits of object count, but isn't weight data critical to gauge material sales income?
Yeah, so my thought on that is this, right? Commodity is sold, frankly, inbound fees are charged based on tons. Commodity is sold based on tons. But how we get to that bale full of material and the commodities means that, I still have to recover each and every object that goes into that bale, and there's a cost to recover each and every object, whether it's applying certain types of equipment that can process that number of objects, or it's employing manual labor to recover it. So it still benefits me to have that object count information and understand, really, frankly, how many picks of material or how many pieces of material do I need to separate into a stream in order to get to that bale of material, which I'm then going to sell by weight, but I've first got to make that bale to begin with. That's just my thought on that.
Great. And another question for you, how do you see the timeline being for having AI at MRFs be prevalent across the U.S.? And are there any hurdles to leap in getting that across the U.S. besides the expense and how cumbersome it is?
Let me address the latter first. So hurdles, none, honestly. These computer vision systems, right? They're pretty straightforward, pretty quick to install. The software is available to run them almost from the day you plug them in. There's always some customization of models that run specifically for those belts or lighting conditions or dust conditions, right? There's always a little bit of variability, and that's where the fine tuning of AI models comes into play. But I would say, again, they can easily be dispersed and installed on a nationwide basis. Just about any plant, anywhere, any line. They're flexible enough. They're easy enough to install. From a cost standpoint, I just think about, again, what's the value of the information? Are you looking at it to know if you have just a lot of leakage? I mean, I've had a camera system in a plant where I identified, $500,000 a year of leakage of aluminum cans. Okay, so that pays for a vision system several fold almost immediately if you can now recover that because you know what's going on. How many folks are worried about whether they're charging their customers the right fee or not, depending on what's inbound, into that MRF. I think there's plenty of examples to show that, it is quite affordable to do either on a limited or line specific basis or on a broad scale within a MRF, really pretty quickly to do that and undertake that.
Great. And this one is for Rob. It's from Denise. She says I'm a part of a material recovery technical advisory group, and I was wondering how we can promote SWEEP for lead projects, and have we started the conversation with USGBC already?
Great question, Denise, and thanks for all your help helping make LEED a better system. We have been talking not only with the True standard, but also with LEED and others at GBCI. So I see a couple of different areas of intersection with SWEEP and LEED. My guess is down the road, it may be required that your C and D haulers be SWEEP certified in order to get that credit. That's one area where I think there can be good overlap because, sadly, we've seen that many haulers are not concerned with putting, assertions about recovery and stuff on letterhead that turns out not to be true. And so having, an additional third-party verification about what happens when the material leaves your doorstep, I think that will be very helpful for folks doing LEED projects. True looks at what's happening within the facility, and so that's how SWEEP and True complement each other. True takes care of what happens inside the building, and then once it leaves the building, that's where SWEEP makes sure that the material that you spent a lot of time, categorizing and getting rid of actually goes and is disposed of as you expect it to be, or that it's actually recovered. And then the other place in LEED where we will probably see some overlap with SWEEP is in LEED for cities. They have the current MR category there needs a little bit of work. And so at least initially, probably what we'll do is we will have SWEEP as an alternative compliance pathway. So become SWEEP certified or do what LEED for cities already asks you. Interestingly, and this is as much an indication that the current structure of the system is, it's just been proven not to work very well. That even though recycling has been at the core of the environmental canon for 50 plus years. I mean, I'm dating myself, but it was the crying Indian who, got me into environmentalism back, in the 60s. And, so, we're trying to, get the industry, which frankly hasn't changed a lot since the 70s, into the 21st century. It's very exciting to see people like Don who are working on cutting edge technologies with a significant amount of industry experience, so that these tools can be applied most effectively and efficiently, and bringing the most value. The good news is that even though recycling as currently constituted is just, it's completely uneconomic and probably in many respects not terribly environmental. We can actually turn it, we can transform it from an expensive but necessary municipal function into a driver of economic development. So I'm very, very sanguine about the future of recycling. You know, it's like recycling is dead, long live recycling. But you know, this is going to have a 21st century bent. You know, why should glass, which has 1/100th the environmental footprint of textiles, get curbside recovery and not textiles, right? From an environmental perspective, it doesn't make any sense. And you know, clearly with the environmental burden, you have associated economic interests. Clearly, textiles are not as easy to sort and recover and process as glass is, but you know, the fact still remains that, you know, from an environmental perspective, recycling needs a significant overhaul if it's to be able to achieve the potential that is intended. So I think that brings us pretty much to our time. Jill, did you want to wrap things up for us?
Yeah, thank you so much. This was a super interesting discussion. Great to hear about all that is happening and could be happening in AI and within SWEEP. Just a reminder that the recording of this webinar will be available on the Green Education and I think also the SWEEP websites within the next week. So if you know someone who would be interested in this information but couldn't join us today, they will be able to get the information that way. And the next SWEEP webinar is coming up on May 27th. So save the date. That one will be related to EPR. And watch your emails. We'll be sending out details with the links and registration and all of that in the days to come. Thanks, everyone.
Thanks for joining us, everyone.